So recording has been started. So see here what we have. So this is basically a topic which is related to regression and correlation. Uh, it does not use probability that we have. It has some probability in it, but we will not use it. So it's like a lecture that we studied before. Like at the beginning, we have 4 lectures where we have all the calculations, right? Finding mean, median, like that. So here also we have the same kind of calculations in table. So basically, this gives you the relationship between two continuous random variables. You see here, it's a relationship between two random variables. But random variables, we studied this concept in probability. So that's why I'm doing this lecture after uh, covering the probability topic. So we all now know what are continuous random variables, right? Continuous random variables are the variables who take values in the intervals. So suppose that uh, for each case observed, we can record these two variables, let's say x and y. So if x and y are recorded, we may look for a linear relationship between them. You know that linear relationship means a straight line relationship. So you see y is equal to b naught plus b1x. This is a straight line relationship, right? In mathematics, usually we write y is equal to ax plus b, straight line. But in statistics, they write x after the constant. And instead of writing them a and b, we are writing them b naught and b1. So it is b naught plus b1x. So basically, b naught is the y-intercept, right? And b1 is the slope. You know that the coefficient of x is the slope of the line. So if slope is 0, this is the line here. If b1 is 0, right? If b1 is positive, it will go up, and if b1 is negative, it will go come down, right? For negative. So b1 gives you the slope. All start from b naught. If I change b naught, it will just start from here, start from here. It just gives you a starting point on y-axis. So x is your independent variable, y is dependent variable. We all know that. But in statistics, in this regression analysis, we call x predictor as well. X is the predictor and y is the response, right? So if you give a value of a predictor, it will predict y. That's why we call it a predictor, because it is predicting the values of y. So y is also called the response. When you give the value of x, you will get the answer, which is y, dependent variable or the response. So here in regression analysis, we want to find b naught and b1. That is there any b naught b1? Now, if you have these two continuous random variables, it is not possible to uh, record all the values, you see, because there are infinite many values for x and y. We cannot record, but at least we can select a sample, right? So maybe we can select sample of values x, I, y, I, let's say, where I goes from 1 to n. It means there are n possible points that I can select out of the population, right? So if I select these points, it may give me, and if I draw all these points, maybe this is x1, y1, x2, y2, x3, y3, x4, x5, x6, x7, x8. So these type of points I can draw here, right? So these are all xi's, yi's here from x1 to xn, y1 to yn. Now, there may be a relationship between them. Let's say if I go to the next slide here, you see, let's say we consider an example where we want to open an ice cream stand, right? And we want to predict how many customers we will get if I open an ice cream stand, right? So you know that in summer season, you may have more customers, and in winter season, you may not have many customers, right? Because ice cream is cold, so people will like it in summer. So temperature can be a predictor for this, answer. How many customers I get depends on the temperature. If temperatures are high, I will get more customers. And if temperatures are low, I may not get many customers, right? So by taking temperature as a predictor, we can collect some data. So what they have done, they have collected the data for 30 weeks from March to July, right? So from March to July, you have 30 weeks. So at every week, you are selecting a data, collecting a data. For week one, the mean temperature was 41 and the consumption per person is 0.386 pints. So this is the consumption of ice cream. Second week, my temperature is little higher, but almost the same consumption. Third week, temperature is even higher and the consumption is also little higher, right? So see, for different temperatures, we are getting different values. So maybe I think this is the smallest one, 28. Maybe this is no 21. 28 is the smallest one, I guess, right? And the highest one is this 72. 72.47, 71.54. So these are when the temperatures are on the higher side. And you see the consumption is also little higher for higher temperature. And when the temperature is small, you see the consumption is also small. So there may be a relationship. We don't know, but there may be a relationship between temperature and consumption. So if I take X as temperature and Y as consumption, I have 30 values. So I have the points X, I, Y, I because I considered 30 weeks. So I have 30 points here. Agree? From X1, Y1 to X30, Y30. So if I draw all these points on a graph, on XY graph, so these are the 30 points. You see, this is the smallest one, 20, and this is the highest one, you see, 0.55 at 71 maybe, right? See, at 71, almost 0.55. So these are all those points, X, I, Y, I, where X is the temperature, Y axis is the amount of ice cream that we consumed per person. Got it? So see, you may see a trend here that when the temperatures were low, my consumption is low. And when the temperatures are higher, my consumption is also higher, right? So we may see a trend here. We may see a straight line trend here. You see, something is going up. Of course, we cannot pass through all the points. Some points are above it, some points are below it. But we may see a linear relationship here, right? This is what we want to find basically. This is the line that we want to find. And the plot that this plot is called the scatter plot. If I just plot the points x1, x2, x3, x4, so on, along with y1, y2, y3, these are called the scatter plot. Okay, the points are scattered all over the place here. So we call it a scatter plot. So scatter plot may suggest, yes, there is a relationship. Let's say if we have a lot of points here and a lot of points here as well, right? It means there is not much we can say about linear relationship. Agree? But if you look at just the black points, I can suggest that there is a relationship between these 2 points. So there indeed appears a straight line trend that I just showed you there, right? Straight line trend is there. How to find that straight line, we will discuss it later. We will discuss this equation a little later. How to find this y is equal to b naught plus b1x. Okay, we will do it, but little later. Before that, if scatter plot is not given to me, only the data is given. Let's say xi points are given, yi points are given. Before looking at this equation of straight line, can we say that there is a linear trend? If there is no linear trend, I may not go to find this line. Agree? So there is a way which can tell us that there is a relationship. Okay, and that is called the correlation between the two variables. Correlation. Regression is something which fits the straight line. You see, I wrote two things here: linear regression and correlation, right? Regression is fitting this straight line, y not b naught plus b1x. Correlation does not give me a straight line. It gives me a coefficient, which is a number, right? Coefficient is a number which is given by R, right? So correlation coefficient is a number R that can tell us whether there is a relationship or not. Okay, so this is the formula for R. You see, if we have X and Y, if we have X and Y, what you can do in this formula, you can see there is a product XY. So I can multiply X with Y, and then there is X square and Y square here. So I can take the square of X and take the square of Y. So if I add all these values, right, I will get sum of X here, sum of Y here, sum of X into Y, sum of X square, sum of Y square. So I have 1, 2, 3, 4, 5 values here. I can replace 1, 2, 3, 4, 5. And this is the same sum of X, sum of Y. So if you replace all the values here, you will get the answer as a number. Now this all these sums are taken from 1 to n. What do we mean? Because see, the values of X are x1, x2 up to xn. Similarly, y1, y2 up to yn. So we are taking these sums. When I write sum of X, it means I'm taking the sum of all values xi from 1 to n. So in short, instead of writing that easily, we can write just sum of xy. It's automatically known that sum definitely will go from 1 to n. Okay, so this is what we mean by this statement here. Your R tells you whether there is a positive relationship or negative relationship. Positive relationship means if one increases, the second also increases. Negative means if one increases, the second decreases. If X increases, Y decreases. Or if Y increases, X decreases. Here, both are either increasing or both are decreasing. Same behavior. So if R is positive, you will have a positive relationship. If R is positive, you will have a positive relationship. Or is negative, you have a negative relationship. So for positive relationship, your line will go this direction, right? And for negative relationship, your straight line will go to this direction, because with the increase in one variable, second is decreasing. R will always be between -1 and 1. It will never exceed these two values. If we get +1 answer, we call it a perfect positive correlation. -1 means perfect negative correlation. It means both R is equal to plus and -1 means we have a perfect correlation. Perfect correlation. Okay. So when I will get that, when all values are very, very close to each other to a straight line like this. If you see all these values are very, very close to a straight line, then R will be approximately 1, very close to 1. Okay, but if values are scattered like this, right, but we still see some relationship, then R will not be very, R will be big, maybe greater than 0.5 or maybe close to 0.5, like that. And if R is close to 0, then no relationship at all. Values are going here and there. No relationship we see in the variables. Okay, so R approximately equal to 0 means no linear relationship between X and Y. There may be some non-linear relationship. We are not looking for that. Maybe the data is going like this. You see, data is going like this, right? You see here, if I follow this, it is going like a curve, maybe exponential relationship. It's a non-linear relationship, right? This may be there, but we are not looking for that. We are not looking for that. We are only looking for linear relationship. Okay. So we can see a simple example here. So see here, in this case, your R will be very close to -1. It's going down. So R will be very close to -1. You see, -970. Now R is very small. And here, yes, there is some relationship. Maybe we are going up, maybe we are going down. So R should be positive here, but close to 0.5. You see, close to 0.5. Or again negative, but close to 0.5. So see, when R is close to 0.5, positive or negative, we have some relationship, but values are very scattered, very scattered. Here you see R is close to 1. We have a relationship and all the values are very close to this line. All right. And here R is close to 0. So I think this picture uh, tells us whole story, right? What different values of R mean, basically. So let's say this is an example where we have 1, 2, 3, 4, 5, 6 values for X. Let's say X denote the mathematics grade for students, Y denote the English grade for some students. And we want to find a correlation coefficient here. So what I can do, you can write in columns. You can write these are actually X i's, Y i's, right? But you can just simply write X, Y, no problem. 70, 92, so on, 74, 84, so on. So if you write all these values, take the square of X, take the square of Y, take the product of X, Y, and get all the sums. Sum of X, sum of Y, sum of X square, sum of Y square, sum of X, Y. So if you calculate, you should get these values. Sum of X, X square, Y square, and X, Y. You can check that. You can verify these values. Very easy to verify. Okay, so putting above values in the formula, this is the correlation formula. I will give you these formulas in the exam. Okay, so don't worry about that. So I will give you this formula, but you should know how to implement that. Okay, so if you put all these values, you can see that R is 0.24. So R is not close to 5. R is not even close to 1. So we can say that yes, there is some linear relationship here, right? Because it's not very close to 0. 0.24 is not a big value for R, but still we can say that yes, there is some kind of relationship between mathematics and English grades. Got it? So now going back to that question, can we find the linear relationship? You see, your true regression line, because we are talking about the population, right? Population variables can they have infinite many values, right? So if we write the true regression line, it is beta naught plus beta 1x. Okay, we write them as beta naught plus beta 1x. That is your y. But these y may not be exactly matching with your values, right? Your exact value may be these blue dots, but what y you are getting, they are the y's on the line. So you see, there is a difference between the actual y's and the observed y. This one. So these are called the errors. We call them epsilon 1, epsilon 2, epsilon 3. These epsilon i's are errors in each case, where the true y and calculated y, there is a difference between them. So this, if this is my calculated value and this is my actual value, so see, there will be a difference of this epsilon, the error term. Okay. But this error term, they have the mean equal to 0. Means if you take the sum of all these error terms, this will come out to be 0. Okay, along with their probabilities, because they say that these error terms is a random variable and this random variable has a normal distribution. So this epsilon is a random variable who follow the normal distribution, right? And their mean and variance are, their mean is always 0 and standard deviation is sigma. So there can be some, because see, there are values of epsilon 1, not all are 0. So of course their variance cannot be 0. There will be variance, but their mean will always be 1. So it follows a normal distribution. These error terms follow the normal distribution with mean 0, and there will be some sigma, of course. So when we have a sample, because these are the population values, infinite many values, we cannot write all of them. So we select a sample. When we select a sample of size n, if we select a sample of size n, xi, yi, right? So it's starting from x1 going to xn, y1 going to yn. And if we uh, find a line from these sample points, then we don't call it beta naught. We then call it b1, b naught plus b1x. So b naught and b1, they are estimates of beta naught and beta 1. We cannot find beta naught, beta 1 because they are from the population. Population has infinite many values. So what we do, we find this line. We find b naught and b1, which are called the estimates for beta naught and beta 1. Okay, and this is called the estimated line or fitted regression line. So when you calculate this and see, we put this y hat is the estimated value. Y hat is the estimated value, y is the actual value. So there will be some difference between them, epsilon. So if I take this, or we can call it E, because epsilon we used for population. So for sample, we can use E for that. The sum of all EIs will be 0. So this is EI. So if I subtract actual value, and this is the fitted value, this is the fitted value, and this is the actual value, actual Y value. Okay, so there will be a difference between them. But again, EIs are very well behaved errors. Their sum is always 0, and their now what we want to do, how I can find B naught and B1. We find B naught and B1